My name's Matt Keenan. I'm a project manager and engineer at AeroVironment Incorporated, located in Simi Valley. And I design and build small unmanned air vehicles. And this came out of a kind of a long history of designing and building model airplanes and toys, which started from when I was a child. Most kids don't realize that they're doing science and engineering when they're just playing. Whether they're making something out of Legos or making some artwork, a paper airplane, and making an adjustment, they're actually doing engineering and science. I didn't realize that when I was growing up, and I found out later that I was actually doing preliminary engineering work. And when it came time to finding a job, it's like, I'm an engineer. Curiosity is very important in my work. We have problems that we're given that nobody else has solved before, and we have to take pieces of solutions that are in other parts of the world. So we might take pieces of a toy or a piece of a sports equipment or who knows what, something right out of the blue, and apply it to this unmanned aircraft to make it work. What we call a UAV, that stands for Unmanned Aerial Vehicle. They have the ability to fly for kind of long periods of time depending on the size. They can fly by themselves using their own navigation system. The UAVs come in all different shapes and sizes and types. If you kind of look around the room, these are fixed wing designs. You see some helicopters. Some of these are UAV prototypes. Some of these are model airplanes. The Nano Hummingbird is the most unusual. It's called an ornithopter. And what that means, that comes from ornithology, study of birds, real birds, and that means flapping wings. So it's a mechanical flapping wing flying machine. So part of the idea was not only to make it look like a real bird, but to investigate how flapping wing flight could perform compared to helicopters, compared to fixed wing airplanes. We picked the Hummingbird because it was about the right size and it had the right type of flying characteristics. So it can fly forward, backward, up, down, rotate, it can hover, it can fly fast. We had to design and test about 300 different wings to come up with the final design. Some had some rubber in them, some had some nylon, cloth fabric, plastics, and you can see the different shapes. And so these were inspired by both biological systems. They're kind of like the way feathers lay out in a hummingbird, in a real hummingbird wing. And they're also inspired by model aircraft that use flapping wings. And then also sailboats and windsurfing sails. So if you turn these like this, all of a sudden these start looking like sails. All of these variations affect how much thrust the wing makes, how noisy the wing is, how well it can be controlled, and how much power it takes to flap, and how durable it is. Real hummingbirds need to basically eat constantly. For every second that they're flying, they need to be eating. And they spend basically all their time perched in a tree, or they're flying to a flower and eating. They're not playing around, they're not goofing, they're not doing stunts and aerobatics, because for every flap of that wing, it takes a lot of energy out of their body. We have the same problem where this takes a lot of power and energy to fly, and that was a big goal from day one, is we had to prove this could fly for several minutes.
Helicopters are actually more efficient than flapping aircraft. The helicopter rotor takes a lot of power at first to get moving, but then once it is spinning, it requires much less power. The flapping aircraft, also called the ornithopter, requires a lot of power to reverse the direction of the wing at the start and stop of each flap, and uses overall more energy than the helicopter.
The most satisfying parts are when you get each little piece working along the way. And then you start putting them together, and then that's satisfying. And it just builds and it builds and builds. You might still have lots of struggles, it may not be working right, but all those little goals, little discoveries or little celebrations that you have, and that's really great to share with the other team members and motivate you to move forward.
Try the activity in the Curiosity machine and build different wings to see which one puts out more thrust.